Yeah. So today we will see the subject quantitative techniques. So in this subject, for the purpose of syllabus here, it is divided into 5 blocks. So block 1, block 2, block 3, then block 8, block 5. So now we'll share the screen. Wait a minute. Yeah. So this is your syllabus. Right. So you see the block number 1, that is introduction to research and data collection techniques. Wait a minute. Right. So here, quantitative techniques and introduction. So need and importance of quantitative techniques, then classification, mathematical quantitative techniques, statistical quantitative techniques, operation research techniques, role of quantitative techniques in business and industry, quantitative techniques in decision making, and limitations of quantitative techniques. So this is the unit number 1 from the block 1. So this is completely theoretical part. So in this theoretical part, we are going to see what actually the quantitative techniques, and here mathematical and statistical quantitative techniques differences. What is mathematical and what is statistical quantitative techniques? We are going to see in this chapter. And the next one is here quantitative techniques in decision making. Even though the quantitative techniques is a good subject and it has a good limitations, what we call merits. In addition to that, some limitations also there. Okay, so this is about the unit number 1. And coming to unit number 2, see here, basics of research. Basics of research means here what actually the research needs. Why? Because for PG students, while they are pursuing their PhD program, so research is plays a vital role in their PhD program. So here, meaning and definition of research, characteristics and objectives of research, criteria of a good research, scope of research, functions or uses of research, difficulties and limitations of research, types of research, methods of research, research methods versus methodology. Okay, so we are going to see in the unit number 2 regarding the basic introduction about the research. In that here, the complete introductory part of the research we are going to see. Then unit number 3 is here, the process of research. So while you are carrying research, okay, after knowing what actually the research is, okay, then we are going to involve deeply. So while you are involving deeply, we need to know the process of research. In this process of research here, selection and specification of problem, development of hypothesis formulation, research process, preparation of research design. Then next unit number 4, that is data collection techniques. So here, not only for doing research here, after knowing the process, what actually, which type of data and what data is required. Okay, that unit number 4, that is the data collection techniques. So planning of statistical investigation. Planning of statistical investigation means a perfect planning is required. Why? Because plan. Plan means what? Generally, the concept of plan is thinking in advance or thinking before doing. So here, for a statistical investigation, so here we are going to apply all the statistical tools and techniques. So we need to go for a investigation. Okay, then here statistical units. Okay, in that statistical units here sources of data. Okay, in source of data there are two types of data, that is primary and secondary data. Methods of collecting primary data: direct. Okay, in methods of collecting primary data is the first one is direct method or personal investigation. Indirect, oral investigation, information through agent and correspondence, mailed questionnaires and schedules. Okay, to be filled by the enumerators. Drafting a questionnaire, census and sampling. Then methods of sampling: random methods of sampling, merits and demerits; non-random methods of sampling, merits and demerits. Okay, comprehensive illustration of the drafting a questionnaire. So we are going to see in this uh, data collection technique chapter. Okay. Then after a collection process is completed. So here, all this comes under basically the 80% of unit is focused on primary data only. Okay. So what is primary data? What is secondary data? We need to know. The next one is unit number 5 is interpretation of data and report writing. After data collection is completed, we go for interpretation of data and report writing. Interpreting all the raw data what we collected. Then based on the report, we go for writing a small report. Based on the data, we are going to write a small report. Then in that here, interpretation of data, source of errors in interpretation is any what we call errors are occurred. Then what are the sources? Then precaution to be taken while interpreting the data. Some precautions are required. Why? Because once a mistake is happened, it is happened, and it's a big loss for the research. Not only for the research, in our daily life also, we are going to see. Okay, so precaution is a very much the basic tool. Uh, okay, the next one is meaning and need for report writing here. Meaning report writing, then characteristics of a good report, components of report, do's and don'ts. Okay, so this is completely block number 1. Then next coming to block number 2. So slowly we are entering into the complete the problematic part here. So here, time series analysis. So relational analysis and forecasting. Time series analysis, that is a definition of time series analysis, significance of time series analysis, preparation of data, adjustments before analyzing time series, components of time series, secular trend, cyclical variation, seasonal variation, random variation, methods of measuring time series analysis, graphic method, method of semi-averages, method of moving averages, least square methods, shifting the trend origin, conversion of trend values, methods of measuring seasonal variations, method of simple averages, method of ratio to trend, method of ratio to moving averages, method of link relatives, methods of measuring the cyclical variations, residual method, reference cycle analysis method, direct method, harmonic analysis method, methods of measuring the irregular variation, additive method, multiplicative method, uses and limitation of seasonal indices, deseasonalization of data, additive process of deseasonalization, multiplication process of deseasonalization. So here in the block 2, in relational analysis and forecasting, we are going to see in the from the chapter number 6. The next one is a see. This is also a little bit theory as well as some problems are involved. Then unit number 7 is, that is correlation analysis. So from this chapter, we are going to see the problems. The problems are looks very easy and very simple problems. If you practice regularly, you are going to solve the problem in the examination and you are going to get good marks. Why? Because see, the subject name, the title indicates quantitative techniques. Okay, quantitative techniques here. So quantitative techniques indicates here, see, what type of quantity is it? Quantity means it's a bulk amount. Okay, the techniques we are going to apply. So in correlation analysis, we are going to see some theoretical concept as well as problematic concept also. So what are the theoretical concepts here? So definition of correlation, that is number one, significance of correlation. Then types of correlation. In types of correlation, we are going to see positive and negative correlation, linear and non-linear correlation, simple, partial, and multiple correlation. Then methods of studying correlation. So there are different methods are there, but in our syllabus, different topics are there. So what are that? The first one is scatter diagram method, correlation graphical method, Carl Pearson's coefficient of correlation, rank correlation coefficient, concurrent deviation method, probable error, coefficient of determination, lag and lead correlation. So this is about the theory has a problematic part from the correlation analysis chapter. Then in addition to that here, the next one is here in block number 2, the regression analysis. Okay, what is regression analysis? So the definition of regression analysis, utility of regression analysis, difference between correlation and regression analysis, regression lines, methods of least squares, fitting regression equation, regression coefficient, standard error of estimate. Okay, so the in regression we are going to see the regression lines. Regression lines means here x and y. So there are two types of regression lines are there, that is x analysis and y analysis. And here Carl Pearson coefficient of correlation. Okay, fitting regression equation, then equation coefficient, we'll see. The next one is business forecasting. Then here meaning of forecasting. Forecasting means estimation about the future. So importance of forecasting, steps in forecasting, forecasting for long-term decisions, forecasting for medium and short-term decisions, forecast control, limitations of business forecasting. So this is completely the theoretical concepts only. So to till unit number 9, see the correlation analysis and regression analysis problematic part is there. The remaining the theory is there. And so here till here we are going to conclude the block number 2. Then block number 3, probability and theoretical distributions. So probability and theoretical distribution, that is unit number 10, elements of probability theory, meaning of probability, the concepts, sample space, sample points and events, types of probability, prior probability, empirical probability, subjective probability, calculation of probability, fundamental rules of probability in case of simple events, in case of mutually exclusive events, in case of compound events, conditional probability, statistical independent events, Bayes theorem, mathematical expectations, appendix, permutations, combinations. So these are the first part of the probability. The next second part of the probability indicates here probability distribution. Okay, in a probability distribution, first one is elements of probability theory. The next one is probability distribution. That is binomial and Poisson distribution. Meaning of random variable, definition of random variable, discrete and continuous random variable, the probability, mass function, expected value of random variable, variance and standard deviation of random variables, importance of random variables, types of probability distributions, binomial distribution, Bernoulli trials, the concept of binomial distribution, parameters of binomial distribution, fitting of binomial distribution, Poisson distribution. See, the concept of Poisson distribution, parameters of Poisson distribution, when to use and how to fit a Poisson distribution with illustrations. Okay, so this is the unit number 11. Then unit number 12. So in normal distribution, the normal distribution, it is also a good and interesting topic. So definition of normal distribution, parameters of normal distribution, characteristics of normal distribution, normal approximation to binomial distribution, and central limit theorem, how to measure the area under normal curve. So generally in the normal curve, it looks like this here. See, like this, normal curve here. So, and this is a baseline. So we are going to see how to measure here. See this part, okay. So this side is 0.5. So always probability will be 1 only. It should not be above 1, like 1.5, like that. So that is 1.5. So 0.5, 0.5. This part is 0.5 and this part is 0.5. If you add both, that is 1 only. So this is the place we call it as X bar, mean. Okay. So 1, 2, 3, 4. See normal curve here. 5. Okay. 6. These values shows a positive sign. So then here, this is a -1, -2, -3. This side, negative inferences. Okay. So, right. The next one is block number 4. So in block number 4 here, statistical estimation and hypothesis testing. Okay. So this is the big chapter and interesting chapter here. So that is the first one is here, unit number 13, that is introduction to testing of hypothesis. Hypothesis, central limit theorem, population, sample and sampling distribution, test of hypothesis, concept of standard error, type 1 error and type 2 error, two-tail and one-tail test, estimation, hypothesis testing procedure. Okay, so this is the complete theory, that is unit number 13. Then come to unit number 14. Test of significance. See, test of significance of attributes, meaning of an attribute, difference between an attribute and variable, estimation and test for number of success, test of number of success, proportion of success, test for proportion of success, and proportion of success, test proportion. The next one is test difference between proportion of success. This is the first topic. The next one is a sampling of variables, that is large samples. Significance of sample, that is large sample. Objectives of studying sampling of variables, difference between large sample and small sample. Assumptions relating to large samples. Estimating population mean, test of sample mean, test of two sample means. Okay, so here in large samples here we are going to see the mean, difference between mean and difference between standard deviation also. Okay, two sample means are given, but we need to see standard deviation also. Why? Because it also includes in that topic. Okay, so I don't know why they removed from the syllabus. I don't know, but thing is, it is also one of the important core topic regarding the standard deviation, difference between two standard deviations. So only two means only asked. So it is good. It's not a problem for the student. So if it is a standard deviation added means it is also nice. The next one, sampling of variables, that is small samples. The concept of degrees of freedom. So we need to see the concept of degrees of freedom. Why? Because we need to carry a table values, table value for examination point of view. Okay, table value for examination point of view to see the degrees of freedom. So then here the students T distribution. T means student T distribution. The name by the pen name. Okay, WS Goset. Generally, WS Goset was working in a factory. So he's very busy with research findings, but no one encouraged him and no encouraged him to publish his research findings. Then he invented a pen. That name is called as T. Okay, that is called as students T distribution. Then here properties of T test. assumptions of t-test, applications of t-test, limitations of t-test, how to refer t-table, confidential interval for population mean, testing of significance of mean of a random sample, test of a single mean, test of two independent samples, difference test here. Okay. The next one chapter is the next important chapter is a chi-square test. Test of goodness of fit, test of independence of attributes, its corrections, choices and limitations of chi-square. Okay, this is the block number 4. Okay, the next one is block number 5, that is a decision analysis. So what you already wrote decision. Decision means here, suppose we are busy with any activity, we need to take a decision. The decision makes the activity whether what we done, the activity is good or bad. It depends on decision only. So decision analysis. Analysis means a detailed examination. A detailed examination. So here statistical quality control. So concept of statistical quality control, methods of statistical quality control, process control, control charts for variables, control chart for arithmetic mean, control chart for range, control chart for standard deviation, control chart for attributes, control chart for the number of defects per unit, control chart for fraction defectives, control chart for number of defectives, advantages of statistical quality control, limitations of statistical quality control. Okay, this is the unit number 19. Then unit number 20, statistical decision theory, nature of decision, elements of decision, statistical decision theory, decision situations, deterministic situations, a risk situation, uncertainty situation, choice of a decision criterion, decision tree analysis, advantage of decision tree analysis, limitations of decision tree analysis. So this is the statistical decision theory. Then the last unit is 21, that is game theory. Okay, game theory. Meaning of a game theory, properties of a game, assumptions of a game, types of games, two-person games and n-person games, zero-sum and non-zero-sum game, two-person zero-sum game, max, max min, max mini and minimax strategies. Maxi max not. This is not maxi maxi. This is minimax and max mini strategies. Okay. So saddle point, dominating strategy. So here, saddle point. This is the first topic. The next one is mixed strategy. Then the last one is a dominating strategy. That is a rules for dominant meaning for dominating strategy. Rules of dominance. Okay. Then solution methods for games, algebraic method, probabilistic method, dominance rule. Then next one is graphic method, linear programming method, the limitations of a game theory. So this is the an overview about the complete syllabus. Okay, complete syllabus. So from these complete syllabus, the interesting topic we are going to start now. So that is very much interesting and very easiest topic for the students. Okay, so I will share the screen now. So wait a minute. Yeah, yeah. Wait. So we see the analysis of variance. Uh, Good, interesting, and very much good topic. So wait a minute. Or we go for correlation. Okay, it is also a good topic. Yes, so it is got it. So I will share the screen now. Yeah. So here I will share the screen. Right. So I think it is visible, everyone. So the topic name is here ANOVA. Okay, ANOVA. ANOVA is nothing but analysis of variance. Analysis of variance. So this is very much interesting topic. So and it is also problematic. So I had chosen this one. So analysis of variance. Today we'll see the complete regarding ANOVA. Okay. Then we go for the next in the tomorrow class the other topic. So you see the ANOVA. ANOVA is also known as analysis of variance, and it is a powerful statistical tool for test of significance. Okay, test of significance means the importance of the test we are going to see with the help of this ANOVA tool. So previously we used a t-test for testing the significance of difference between two sample mean, that is H naught, mu1 is equals to mu2. But when we have three or more samples to consider at a time, we can use F test. That is for testing the hypothesis that all the samples are drawn from the same population, or there is no significant difference between K sample mean. That is H naught, mu1 is equals to mu2, mu2 is equals to mu3, so on mu k. This can be done by using the technique ANOVA. Thus, basic purpose of ANOVA, the homogeneity of several means. So all the samples, what we are going to draw, they should belongs to only one family only. So for example, 5 fertilizers are applied to 4 plots, each of wheat and yield of wheat. Okay. On the effect of these fertilizers on the yield is significantly different, or in other words, whether the samples have come from the same normal population. The answers to these problem is provided by the technique of analysis of variance only. So all these fertilizers generally we will use in agriculture, and yield of wheat. Wheat belongs to agriculture family only. So homogeneity of several means they should belongs to one family only, all the samples. So the term analysis of variance was introduced by Professor Ronald A. Fisher in the year 1920. To deal this problem in the analysis of agronomical data variance is inherent in nature. The total variation in any set of numerical data is due to number of causes, which may be classified as assignable causes and chance causes. The assignable causes can be detected, can be determined, can be estimated, can be measured, whereas the chance cause cannot be determined, cannot be measured, but it is under the control of human and cannot be traced separately. The next one is here, assumptions in the analysis of variance. So what are the assumptions? Generally, in any area, assumptions will be there. So in analysis of variance, there are some assumptions will discussed. Okay, so coming to F test here. See, F test or analysis of variance test, ANOVA test, or radar A Fisher test. All the names are similar. Okay, the examiner will ask in any way. So here for the first assumption is normality, homogeneity, independence of error. Normality. Normality means here, see if you observe the problem very clearly, the problem will be like this. See, A, B, C, then D. So here schools. How many schools are there? There are four schools are there. School A, B, C, D. So under school, different values are there, different classes here like this. 10, 15, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6. So if you see these data, it looks very normal and homogeneity. See, school belongs to the educational family. So, regarding the while we are conducting the survey, while we are conducting the research, so here all the data should belongs to one area only. It looks normality and the sample what we collected, they belongs to one group, that is homogeneity and independence of error. So see, there is no scope for error and all the samples are independently, they are not dependent. Okay, this is about the assumptions. The next techniques. So what are the techniques we are going to see? Generally in ANOVA, see there are two types of techniques are there. Wait a minute. ANOVA one-way classification, and here ANOVA two-way classification is there. So directly, at the time of preparing the notes, I have prepared directly. So see, techniques. For the sake of clarity, the technique of ANOVA has been discussed separately for the steps. These are the different steps are there. So see, before we are going to see the step, directly we go for a specimen. Specimen is important here. So generally, you observe carefully calculation of variance between samples and within samples. Then last one is a calculation, calculate the ratio F has follows. This is the F. F indicates for Fisher's distribution. Okay. So then after getting the value, we go for the comparison of the calculated value with the table values. So first, if we are going to do the problem, so this is very much important. It is customary to summarize calculations for sum of squares together with the number of degrees of freedom and mean squares in a table called analysis of variance table, generally abbreviated ANOVA. So the specimen of ANOVA table is given below. So you see the specimen carefully. Okay, this specimen is important. If you had this specimen, if you had this specimen, it is very simple and very easy to solve the problem analysis of variance. Analysis of variance. So you see carefully. Generally, there are five heads will be there. That is source of variations. Source of variation, sum of squares, degrees of freedom, mean sum of squares, variance, ratio of F. So between samples, within samples, between samples, within samples, between samples, within samples, then total. So between samples, sum of squares, that is SSC, sum of squares between samples. Then degrees of freedom, V1 is equals to C minus 1. Mean squares, MSC is equals to SSC divided by C minus 1. Okay. Then within samples, that is SSE. V2 is equals to N minus C. MSC is equals to SSE divided by N minus C. Then you are going to get the MSC value and MSE. The total is SST. So K is equals to N minus 1. So here, the last one is MSC divided by MSE. Okay. If you see the problem, then you are going to get the idea. So before that, once again, you see this table carefully. You observe carefully. This table is very much important. This table plays a vital role in solving the problem. So you observe carefully, my dear students. Here, see SSC. First, we need to find out the sum of squares between samples value. Okay. Then V1. So degrees of freedom. Generally, degrees of freedom is nothing but here. See, degrees of freedom always N minus 1 will be there and separate table values will be there. Okay. Then mean squares. MSC. MSC is equal to, you observe carefully. See, already SSC we got the value. SSC divided by C minus 1. Then you will get a MSC value. Then within samples, that is SSE. V2 is equals to N minus C. Okay, V2 is equals to N minus C. So MSC is equals to, see, MSC is equals to SSE and V2 is equals to N minus C. SSC divided by N minus C. Then SST. K is equals to N minus 1. So whereas SST, total sum of squares of variations, SSC, sum of squares between samples, that is columns, SSE, sum of squares within samples, MSC, mean sum of squares between samples, MSE, mean sum of squares within samples. So here the node number 1 is important and node number 2 is important. See, the same procedure for analysis of variance is applicable for both equal and unequal samples. See, equal and unequal samples. This is very much important. So, for example, you see this table. I will draw one small question. See, this is the school's problem. So, school's problem we are going to do. Okay. The next coming pages. So, you observe carefully. School. So, how many schools are there? Generally, schools A, B, C, D, or sometimes it will increase also or decrease. This is A, B, C, D. So values will be there. 2, 5, 6, 9. 1, 2, 3, 4, 5, 10. Okay. 5, 1, 2, 3. So you observe carefully this table. Schools A, B, C, D table. So in this school A, B, C, D table here, generally the schools A, 4 samples are there. That is 2, 1, 2, 5. It school B 5, 3, 4, 1. School C 6, 5. Then no value and 2. 9, 10. Again value is empty. Then 3. Okay. So this type of question is called as unequal value, unequal sample size here. So all equal sample sizes are not taken. So this is one case. Then another one is here. For example, the value will be there here. Value will be there. That is 4. This is 7. So all these this question indicates here equal values. Okay, equal values. Unequal, equal. You got the difference. So unequal value question is given. Equal value question is given. Okay, the same procedure you have to follow. In procedure, there is no change. Then note number two. This is note number one. Then coming to note number two, assume a 5% level of significance if LOS is not given in the question. So this is the question. See, school ABCD, this is a question, and apply ANOVA. Examiner will be given like this. Apply ANOVA. We don't know two-way ANOVA or one-way ANOVA. So which type of ANOVA we need to apply? Either one-way or two-way. Okay, either one-way ANOVA or two-way ANOVA we need to apply. That is important. Yes or no? So here, the level of significance. Level of significance means in the given question, if 5% level of LOS is given, 5% LOS, one small line, that is 5% LOS or 1% LOS. Or sometimes LOS is not given. LOS is not given. So what we have to do? If LOS is not given means we have to assume that 5% LOS only. 5% LOS only. Okay, 5% LOS only. If 1% is given means we have to follow 1%. If nothing is mentioned, then what we have to do? We have to follow 5% only. Okay, this is about the ANOVA one-way classification model table. Now we are going to see the problematic part. Directly we are entering into problem. So you, my dear students, please keep a notes. Very much an interesting problem. So this is the problem. This is the problem. Okay, so please go to the problem. I'll be back in 1 minute. Yeah. So here you observe carefully to assess the significance of uh, to assess the significance of possible variation in performance in a certain test between grammar schools of a city. A common test was given to a number of students taken at random from the senior fifth class of each of four schools concerned. The results are given below. Make an analysis of variance of data. The schools A, B, C, D. So four schools are there. See, previously what we discussed, see, all these values are equal values. These values also equal. See, all the places are occupied. So equal model question. This is equal question. Okay, I think you clarified that doubt. So first, after observing this type of question, what we have to do means here, calculation of see answer, you see the solution, calculation of ANOVA. So instead of A, B, C, D, just write the sample 1, sample 2, sample 3, sample 4. That is x1, x2, x3, x4. x1, x2, x3, x4. Okay, x1, x2, x3, x4. So same question. Till here, the same values we are taken from the question paper. All these values we copied from the question paper only. See, if you understood the question paper, all the questions clearly, then completely it is a half solved. Your exam is 50% you completed your exam. So the next one, the very part is you have to write all the answers in the paper. So sample 1, sample 2, sample 3, sample 4. So sample 1, you do the total 8, 10, 12, 8, 7, that is 45. Then 12, 11, 9, 14, 4, that is 50. 18, 12, 16, 6, 8, that is 60. 13, 9, 12, 16, 15, that is 65. So after doing the total, just get the average of above values. That is the total is 45. 45 divided by 5. This one. Wait. This 45 divided by number of observations, 5 observations are there. You get 5, 9. 50 by 5, you will get 10. 60 by 5, you will get 12. 65 by 5, you will get 13. So this is average of sample 1, sample 2, sample 3, then sample 4 average. The next now starts actually we are going to calculate SSC value. We are going to calculate SSC value. Okay. That is the first step is grand mean of averages. Okay. X double bar called as grand mean of averages. That is X double bar is equals to X bar 1 plus X bar 2 plus X bar 3 plus X bar 4 divided by number of samples. That is C, number of samples. X bar 1, X bar 2, X bar 3, X bar 4 divided by C, that is number of observations. Okay, X double bar is equals to, say X bar 1 is 9, X bar 2 is 10, X bar 3 is 12, X bar 4 is 13 divided by 4. So the total 9 plus 10 plus 12 plus 13 is equals to 44 divided by 4 is equals to 11. Then grand mean of all samples. Grand mean of all samples that is X double bar is equals to sigma X1 plus sigma X2 plus sigma X3 plus sigma X4 divided by N. N stands for total number of samples. How many total number of samples are there? 20. So sigma X1 45, sigma X2 50, sigma X3 60, sigma X4 65. That is 220. 220 divided by 20, we got 11. So in the first case, average case and all sample case, you see, observe carefully. This level and this level. So in the first case, we got 11 and the second case also we got 11. So what calculation we are doing, that calculation is correct according to this. Okay. Then next, after getting these values, now we are going to start the variance between sample. That is, we need to find out the SSC value. Variance between samples. Variance between sample. So here, to obtain variation between samples, calculate the squares of the deviation of the various samples from grand average. For example, say the mean of sample 1 is 9, but grand mean is 11. So we will take the difference between 9 and 11 and square it. Similarly for sample 2, the mean is 10, but the grand average is 11. And so we will take the difference between 10 and 11 and square it. Thus, we will we will have the following table. So you observe carefully. For the first sample, 9 and 11, and simply we have to square it. So 9 minus 11. How much? 9 minus 11 is, wait a minute. 9 minus 11. 9 minus 11. That is 2. 2 square. We got 4, 4, 4, 4. Then total 20. Then second one, sample 2. 10 minus 11. 10 minus 11, that is 1. 1 square, 1, 1, 1, 1. That is 5. In this case, also same. In this case, also same. So do these totals. 20 plus 5 plus 5 plus 20. Okay. Sum of squares between samples is equals to 20 plus 5 plus 5 plus 20 is equal to 50. This is the SSC value. This is the SSC value. This one, SSC value we got. The next step is degrees of freedom. That is V1 is equals to C minus 1. C stands for columns. How many columns are there? There are 4 columns are there. There are 4 columns are there. So 4 minus 1, that is 3. V1 is equals to 3. Then immediately next column. Next column means we have to remember the specimen of ANOVA one-way classification. Okay. Mean sum of squares between the samples is mean sum of squares. That is SSC divided by C minus 1. SSC is 50 and C minus 1 is 4 minus 1. That is 16.7. Okay. 16.7 here. So we completed the upper part between samples we completed. Now we are going to do within samples. Here, find the sum of squares of deviations of various items in a sample from the mean values of respective samples. Thus, for the first sample, mean is 9, and so we will take the deviations from 10 and so on. The square deviations are given in the following table. So you observe carefully. Sample 1, sample 2, sample 3, sample 4. So x1, we copied the values from the question paper. 8, 10, 12, 8, 7. The next x2, 12, 11, 9, 14, 4. x3, 18, 12, 16, 6, 8. Then x4, 13, 9, 12, 16, then 15. Okay. So what, from where we taken these values? So we have chosen these values from the question paper itself. So here x1 minus x bar 1 square. x1 is 8, x bar 1 is 9. 8 minus 9, 1. 1 square, 1. Okay, any doubt, anybody? Right. See, 9, 8 minus 9, that is 1. 1 square, 1 only. 10 minus 9, 10 minus 9, 1. 1 square, 1. 12 minus 9, that is 3. 3 square, 9. 8 minus 9, that is 1. 1 square, 1. Okay. Then 7 minus 9, that is 2. 2 square, 4. So you do these totals. Then we got 16. So this is a sample 1. The same procedure will be applied for sample 2, sample 3, sample 4. Okay. That is x2, 12, 11, 9, 14, 4. x2 minus x bar 2. So what is x bar 2 value? Okay, x bar 2 value, what you observe carefully. Okay. So any doubt, anybody? So wait a minute, we'll see the average values. See 20, 9, 10, 12, 13. 9, 10, 12, 13. 11 minus 10, that is 1. 1 square, 1. 9 minus 10, 1. 1 square, 1. 14 minus 10, 16. See, 14 minus 10, that is 4. 4 square, 16. 4 minus 10, that is 6. 6 square, 36. Then next one, sample 3. x3, That is x3 minus x bar 3 whole square. That is 18 minus 12. So you got 6 square 36. 12 minus 12, 0. 0 square 0. 16 minus 12, 4. 4 square 16. 6 minus 12, 6. 6 square 36. 8 minus 12. 8 minus 12 means here you got 4. 4 square 16. That is 104. In the same manner, apply for the sample 4 also. Okay. So this is the variance within the samples values we got. That is 16, 58, 16, 58, 104, with 30. Okay, that is 208. That is SSE values. The degrees of freedom. V2 is equals to N minus C. V2. 20 minus 4. 20 minus 4, that is 16. So mean sum of squares within the samples, mean sum of squares within sample is equals to 208 divided by 20 minus 4. That is 208 minus 6 divided by 16 is equals to 13 MSC. It is okay. So after completion of this table, what table we had? The specimen. So you write the specimen. In specimen, first two is between sample and within sample, SSC. So SSC value, how much you got? That value you have to write. Then V1 is what? You have to write. Okay, mean squares, you have to write. Then MSC. Okay. Anybody in doubt? Okay. So if you have any doubt, please raise your hands and you can ask the doubt. So I have a doubt that, so what calculations we done, whether the problem is correct or not. So there is a one question mark is there in the mindset of a student. So to clarify such doubt, you observe carefully. It is advisable to check up the calculations by finding out total variation. Total variation is calculated by taking the squares of deviations of each item from the grand average. From the grand average. Okay, wait a minute. Yeah. So x1, x2, x3, x4. Same question. Then here x1 minus x double bar. 8 minus 11. That is 3 square, 9. Okay. 10 minus 11. It is 1 square, 1 only. 12 minus 4, 11. 1 square, 1. 8 minus 9. 8 minus 11. 7. Okay. So just so we are going to see the difference. It is square 9. Yes. So you got 36. The same procedure apply for sample 2, sample 3, sample 4. 36, 63, 109, and then 50. The total sum of squares. Total sum of squares, that is 36, 63, 109, 50 is equals to 258. The degrees of freedom. K is equals to n minus 1. That is 20 minus 1 is equals to, that is 19. Okay. So you observe carefully this table. I'll be back in 1 minute. Yeah. Okay. So after getting a seed, it is advisable to check. So if you have any doubt regarding the calculation, calculation in the sense what calculations you've done, if that calculation is wrong, that doubt is there means you go for checking this table. It is advisable to check this one. Otherwise, no need to do this table, the last one. So after getting all the values, you observe carefully. After getting all the values, what table we had, okay, that is the specimen. According to that specimen, you have to interpret all the values. Source of variations between samples, within samples, sum of squares, degrees of freedom, mean squares. So you observe carefully. This is a 50 SSC value and V1 is equal to 3 we got, and MSC divided by MSC mean sum of square, that is 16.7. 16.7 mean squares. This is not a F value. Again, we go for doing the M value also. So generally, I have written here only four columns. Another column variance ratio of F also you can add. You can add here one more column. Otherwise, you can write separately like this. F variance between samples divided by variance within sample. So I think you got this is 208 SSE, then V2. Then here 13.0. Okay. Then these totals 258. 3 and 6, that is 19. Okay. So F is equals to 16.7 divided by 13.0. So the final answer is here 1.285. 1.285. This is the final answer. So these values called as, see, these values called as CV, calculated value. This value is called as CV, calculated value. So after getting this value, we go for a comparison. So you see the comparison here. Carry ANOVA 5% and 1% table values. So the comparison is there like this. Conclusion here, or comment you can write, or decision you can write according, that is your wish. Why? Because statistically we are doing problems based on getting the answers, the numbers, we got the answers based on the number. The number is a positive or negative or zero number. On that number only we are going to take the decision here. So comparison of calculated value with the table value, or the table value is also called as critical value. Critical value. Okay, are you getting my point? Critical value. So here, table value of V1 is equal to 3. See, V1 is equal to 3. See, you observe carefully, I will show. V1 is equal to 3 and V2 is equal to 16. At 5% yellow is in table values. The answer is, that is 3.24 is there. So these 3.24 should be compared whether it is less than or greater than with the value what we got 1.285. Calculated value of F is less than the table value, and hence the difference in the mean values of sample is not significant. We accept H naught. So in this way, we need to write the answer. So I think you understood this problem. If you have any doubt, you can ask the doubt. So we have 20 minutes time. In these 20 minutes, if you have anybody you have any doubt, you can ask the doubt. Okay. We go for the two-way classification now. So we are going to conclude this chapter also. Okay. And shortcut method also there, but it is not required now. So we have only less time. In this less time, it is not possible to cover the whole, all the units, 21 minutes. Just I'm focusing on all very much important topics only. So this is one more you see properly problem. Then ANOVA two-way classification model. This is a second method in ANOVA. For this also, we have a separate specimen. Okay. So we have only 20 minutes. In these 20 minutes, I'll try to complete this topic. Otherwise, we will see in the next class. Why? Because these topics are very much important. Gunshot questions will be there. And if you solve these problems are very easy and very simple problems. If you practice, then you are going to solve the problem. In the examination point of view, you will get more score. Okay, so in one factor analysis of variance explained above, the treatments constitute different levels of a single factor, which is controlled in the experiment. Many situations in which the response variables of interest may be affected by more than one factor. So one factor is affecting another factor. Then there itself, the ANOVA two-way classification will be involved. So for example, you see the different examples. Sales of max factor cosmetics. Sales of max factor cosmetics. In addition to being affected by point of sale, display might also be affected by price charged, the size and or location of the store, or the number of competitive products sold by the store. Similarly, petrol mileage may be affected by the type of car driven, the way it is driven, road conditions, and other factors in addition to the brand of petrol used. See, one factor is affecting the other factor. That's why the two factor analysis we can say. One factor is affecting the another factor. Okay. So you observe carefully. Price charged, the size or the location of the store, or the number of competitive products sold by the store. Petrol mileage may be affected by the type of car driving. See which car we are driving. That car may affect the petrol mileage and in the road condition also. And in addition to that, which type of petrol brand we are using. That is also important. When it is believed that two independent factors might have an effect on the response variable of interest, it is possible to design the test so that an analysis of variance can be used to test for the effect of two factors in simultaneously. Such a test is called a two-factor analysis. With a two-factor analysis of variance, we can test two sets of hypotheses with the same data at the same time. In a two-way classification, the data are classified according to two different criteria or factors. The procedure for analysis of variance is somewhat different than the one followed while dealing with the problems on some one-way classification. In two-way classification also, the following table takes in the following form. Okay, you observe carefully. Source of variations, sum of squares, degrees of freedom, mean sum of squares, variance ratio of F. Okay, so between samples or between columns, between rows, and one more row we are going to add here, that is a residual or error, then total. Okay, so previous in one-way classification variance between samples and variance within sample is there, but here residual or error is added one more. Residual or error is added one more. Okay, so here again 5 columns. Source of variations, sum of squares. Okay, source of variation, sum of squares. Then degrees of freedom, mean sum of squares, ratio of F. Between samples, columns, SSC, V1 is equal to C minus 1, MSC is equal to SSC divided by C minus 1, MSC divided by MSC. Okay, you observe carefully. Just I am reading. Again, I will explain, don't worry. SSR, V1 is equals to R minus 1. See, V1 in the first column and in the second column also we got V1 two times. This is very much important. Carefully, you have to observe. So the next MSR, then MSR divided by MSC. The residual are error, SSC, then V2. Okay, that is C minus 1 into R minus 1. MSC is equals to SSC divided by C minus 1 into R minus 1. Then total, that is K is equals to N minus 1. So you observe carefully. Between samples, that is columns or between samples, you can write. Between rows, residual or error. First one is SSC, sum of square SSC. V1 is equal to C minus 1. So MSC is equals to SSC divided by C minus 1. This value divided by this value, then you will get MSC value. The next one, SSR. V1 is equals to R minus 1. MSR is equals to SSR divided by R minus 1. Okay, then SSE, V2 is equals to, see here V2, C minus 1 into R minus 1. This is V2. Then MSC is equals to SSE divided by C minus 1 into R minus 1. Then SST, K is equals to N minus 1. Okay. So we will see the problem. So when comparing with one-way classification and two-way classification, in one-way classification, you need to write only one conclusion, but in two-way classification, we need to write two conclusions. There is MSC, variance ratio of F for the first time and variance ratio of F for the second time. Okay. So here, conclusion 1 and conclusion 2. In this way, you have to write. So we go for, we will see the problem. A tea company appoints 4 salesmen, A, B, and C and D, and observe their sales in 3 seasons: summer, winter, monsoon. The figures in lakhs are given in the following table. That is seasons, salesmen, summer, winter, monsoon. A, B, C, D. 36, 36, 21, 35, 28, 29, 31, 32, 26, 28, 29, 29. Okay, then salesman total. So you, my dear students, you observe carefully here. In examination point of view, till here only the examiner will be, he will give seasons total and salesman totals we need to do. But fortunately, in this given problem, everything is given. So why we are giving importance for this one means at the time of doing the problem, you are going to understood. So you observe carefully. Okay. So here note. Note is important. Note number 1. Use coding method subtracting 30 from the given number. That is a code note number 1. Coding number. So the question is given by the examiner, and if examiner mentions the code number 30 like this, if the word is mentioned, code number 30, so that 30 should be considered. Otherwise, if this code number 30 is not given, then go for note number 2. That is, the above point is not given, then do. That is 360 divided by 12 is equal to 30. Sir, what is this 360, sir? You will get the doubt. Okay. So you observe carefully. I will solve that doubt. Wait a minute. Right. See, this is important here. See, this 36, 28, 26, that is 90. 36, 29, 28, that is 93. 21, 31, 29, that is 81. 35, 32, 29, that is 96. Okay. This is column 1, column 2, column 3, column 4 totals. Then row 1, row 2, row 3 totals. 36, 36, 21, 35, 128, 28, 29, 31, 32, 120, 26, 28, 29, 29, 112. That is 360. So this is the 360. These 128, 120, 112, and all these 90, 93, 81, 96 totals. These total is called as GT, that is grand total. Grand total divided by 12. 12 means number of samples 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here that is divided by 12. So we will get a 30. Okay. So these 30 is important. What we have to do with this 30? Okay. If the code number 30 is not mentioned, so in this way we have to find out the code number. In this given problem, we got 30. Sometimes what happens in another problem, while we are doing in the examination point of view, so we will get another number 40, 45, or 32, or 25, 28, 29, any number. That number should be considered for coding method. Okay. So now our solution will begins. So you observe carefully. Right. This is the answer. You observe carefully. Above data are classified according to criteria. Salesmen, seasons. In order to simplify calculations, we code the data by subtracting 30 from each figure. The data in the coded form are given below. That is season, uh, salesman, seasons total, salesman total. Okay. See, I am written here 30 here. You observe carefully. 30 I have written here. 30, 30, 30, 30. So this 36 is given in the question. 36 minus 30 plus 6. 36 minus 30 plus 6. 21 minus 30 minus 9. 35 minus 30 plus 5. 28 minus 30 minus 2. 29 minus 30 minus 1. 31 minus 30 plus 1. 32 minus 30 plus 2. 26 minus 30 minus 4. 28 minus 30 minus 2. 29 minus 30 minus 1. 29 minus 30 minus 1. So in this way, you are going to get the values. So you observe carefully. See, plus 6 plus 6, 12. Then plus 5. 12 plus 5, how much? 17. 17 minus 9 plus 8. Okay. The next one. See, 28 minus 30. So plus 6 plus 6 minus 9 plus 5 minus 2 minus 1 plus 1 minus plus 2. Okay. So this is 0. This is minus 8. Okay. The next one, this also. See, plus 6 and minus 6, 0. Plus 6 minus 3, that is we got 3. Minus 9 plus 1 and minus, this is 9. And this is, then grand total is 0. See, sometimes you will get 0, but sometimes you never get 0 also. Then correction factor. The next one is correction factor. This is one more additional formula, small formula. Correction factor is equals to t square by n. 0 square by 12, that is 0. And number of total individual sample is 12. Okay. So this is the first part we completed. Now, in how the SSC value, sum of squares between samples is started in the same manner here. Between salesmen will begins here. Sum of squares between salesmen. This will be obtained by salesman total, dividing each total by the number of items including in it, adding these figures, and then subtracting the correction factor from them. Thus, sum of squares between salesmen is equals to sigma x1 whole square by r plus sigma x2 whole square by r plus sigma x3 whole square by r plus sigma x4 whole square by r minus t square by n, correction factor, t square by n, that is correction factor. So what is this sigma x1 whole square? That is 0. 0 square by 3. R stands for rows. How many rows are there? 3 rows are there. Okay. 0 square by 3 plus 3 square by 3 minus 9 square by 3, 6 square by 3 minus 0 square by 12. So here you observe carefully. First one is 0, the second one is 3, then 27, then 12, then the final SSC is equals to 42. SSC is equals to 42. Then degrees of freedom. V1 is equals to C minus 1. That is 4 minus 1 is equals to 3. Mean sum of square between columns is equals to SSC divided by C minus 1. That is 42 divided by 3 is equals to 14. Is equals to 14. Then degrees of freedom. V1 is equals to C minus 1. Okay, that is 4 minus 3. 4 columns minus 1. That is equal to 3. Then mean sum of square between columns. SSC divided by C minus 1 is equals to, that is 42 divided by 3 is equals to 14. MS is equals to 14. Okay, then sum of squares between seasons. This will be obtained by dividing the squares of seasons total by the number of items that make up each total, adding all such figures and subtracting there from the correction factor. Thus, sum of squares between seasons is equals to sigma y1 square by c plus sigma y2 square by c plus sigma y3 square by c minus t square by n. Y1, see, Y1, Y2, Y3, 8, 0, 8. Hmm? Yeah, I'm getting my point, my dear students. Wait, 22. Yes. 8 square by 4, 0 square by 4, 8 square by 4, then 0 square by 12. SSR is equals to 16 plus 0 plus 16 minus 0 is equal to 32. Then degrees of freedom. V1 is equals to R minus 1. That is 3 minus 1 is equals to 2. Then mean sum of squares is equals to SSR divided by R minus 1. That is 32 by 2 is equals to 16. 32 by 2 is equals to 16. Okay. So see, according to table, SSC value we got, SSR value also we got. The next residual or error. Next step is residual or error, but generally it is for that residual or error, there is a separate way is there to calculate. Before that, total sum of squares we need to find out. Total sum of squares. This will be obtained by adding the squares of all the items in the table and subtracting the correction factor. Therefrom, thus, total sum of square is equals to, see, these values: 6, 6, 6, 2, 4, 6, 1, 2, 9, 1, 1, 5, 2, 1. Okay. 6 square plus 2 square plus 4 square plus 6 square plus 1 square plus 2 square plus 9 square plus 1 square plus 5 square plus 2 square plus 1 square plus minus t square by n. 210 minus 0, that is 210. Then degrees of freedom is equals to n minus 1, 12 minus 1. So after getting all the values, you should interpret in that table. That is source of variations between column salesmen, between rows seasons, residual or error, sum of squares, SS is equals to 42, SSR is equals to 32, V1 is equal to 3, V1 is equal to 2, and V2 is equals to 6. You observe carefully. See, 210 we got. 210. See, total is equals to 210. You see this one. 210 minus 42 plus 32 is equals to 136. Then DOF, degrees of freedom, is equals to 11. 11 minus 3 plus 2, that is 6. Okay, we got the answer. Then mean squares. 42 by 3, 14. 32 by 2, 16. 136 by 6 is equals to 22.67. So MSE divided by MSE. This is MSE value. This is a 14 and this one. Then next one is 16 and this one. Okay. 2 times we done our calculation. See, conclusions we have to write. Okay. So you observe the, see, I will take 1 more minute. My dear student, this is the last topic. So we completed this chapter completely. So let us take the hypothesis that there is no difference between the salesmen of seasons, sales of season, salesmen and of seasons. In other words, the three independent estimates of variance are the estimates of variance of a common population. Now first compare the salesman variance, estimate the residual area is F is equals to 14 by, see 14 divided by 22.67, that is 0.617. And the table value of F for V1 is equal to 3 and V2 is equal to 6 at 5% level of significance. Table value, that is 4.76 is there. So this 0.617 is less than 4.76. The first case, we accept H naught. Okay. In the second case here, F is equal to 16. See, F is equal to 16 here, divided by 22.67. Okay. Again, we got the value that is here. See, accept the critical value for F V1 is equal to 2 and V2 is equal to 6 at 5%. Level of significance is 5.14. The calculated value is less than the table value. We conclude that the seasons are different. Hence, there is no significant. We accept H naught. So another conclusion is there. If in the both case less than is there or greater than them, so it is required to write only one conclusion only. The calculated value is less than table value for both situations. There is no significant, hence it is accepted. If it is greater than, the calculated value is greater than the table value in both situations, there is a significant, hence it is rejected. In this way, you have to write. Okay. So this is for your practice problem. Please, if anybody is interested, see sometimes what happens, use coding method substituting 40 directly given by the examiner. Then only you have to consider this 40 only. Don't go for doing grand total. Okay. Right. So this is one more problem. See, already the calculations are done. But if you want to take a screen